This training session will cover ProProv. ProProv is a language and system for specifying provenance policies over graphs representing the provenance of secure computations. Policies in ProProv can be expressed as logical statements or predicates over provenance graphs. ProProv also contains a graphical user interface to specify and test policies. Now let's introduce the syntax of the ProProv language. We use T as a generic variable to range over the possible provenance node types, which includes account agent, node agent, agent, data entity, contract entity, key entity, entity, and activity. The agent type means that the node can be either an account agent or a node agent. The entity type means that the node can be either a data entity, a contract entity, or a key entity. Next, we use E as a generic variable to range over possible edge labels, which are the provenance relations between nodes. The possible edge labels are was derived from, was attributed to, was generated by, used, acted on behalf of, and was associated with. Next, we use X as a generic variable to range over variable names, which can be any string. Next, we use N as a generic variable to range over provenance node names, which can also be any string. And we use P as a generic variable to range over provenance policies, which can be the negation of a policy P, the conjunction of two policies, the disjunction of two policies, the for all keyword followed by a variable, a colon, a type T, a dot, and a policy P, and can be pronounced for all X of type T, P holds. Next, a policy can consist of the exist keyword followed by a variable, a colon, a type T, a dot, and a policy P, and can be pronounced there exists an X of type T such that P holds. Next, a policy P1 can imply a policy P2, and lastly, a policy can consist of an edge label followed by two nodes separated by a comma and enclosed in parentheses. The negation policy asserts that policy P is not true. We can specify a negation policy using the graphical user interface by clicking the drop-down policy menu and selecting Not. After making this selection, another drop-down menu will appear for another policy selection. The pane at the bottom right of the screen will print the policy in the ProProv language as it is constructed. The conjunction policy, also called logical AND, asserts that both policy P1 and P2 are true. This policy can be specified using the interface by clicking the policy drop-down menu and selecting AND. After this selection, two more policy menus will appear for P1 and P2. The disjunction policy, also called logical AND, asserts that either policy P1 is true, policy P2 is true, or both P1 and P2 are true. This policy can be specified using the interface by clicking the policy drop-down menu and selecting OR. After this selection, two more policy menus will appear for P1 and P2. The universal policy asserts that policy P is true for every provenance node of type T. Variable X can be used in P. This policy can be specified using the interface by selecting For All. After this selection, three boxes will appear: a typable box to enter a variable name, a drop-down menu to select a provenance node type, and a drop-down menu to select a policy. The existential policy asserts that policy P is true for some provenance node of type T. Variable X can be used in P. This policy can be specified using the interface by selecting Exist. After this selection, three boxes will appear: a typable box to enter a variable name, a drop-down menu to select a provenance node type, and a drop-down menu to select a policy. The implication policy asserts that if policy P1 is true, then policy P2 is true. This policy can be specified using the interface by selecting Implies. After this selection, two boxes will appear for policy P1 and policy P2. The edge policy asserts that there is an edge with label E between node N1 and node N2, where E can be any one of 6 provenance relations, which includes was attributed to, was derived from, was generated by, used, acted on behalf of, and was associated with. This policy can be specified by selecting any one of the edge relations. After the selection is made, two boxes will appear for node N1 and node N2. Now let's look at some examples of how we can construct provenance policies using the ProProv interface. During this study, the panel on the right will have 5 input provenance graphs to test your policy on. A graph that has a green check mark means that the graph should satisfy your policy. A graph that has a red X means the graph should violate your policy. Now let's construct a policy to ensure that activity average use data entity salary B. We can construct this policy by selecting Use, then typing average as the source node and salary B as the destination node. We can then evaluate our policy on the input graphs by clicking the Evaluate button. Next, we want to write a policy to ensure that data entity average salary was not derived from salary C. We can construct this policy by first selecting not, then selecting was derived from. Then we can type average salary as the source node, and we can type salary C as the destination node. Next, we want to write a policy to ensure that activity average used key entity key B and key B was attributed to account agent Bob. We can construct this policy by selecting and, then for the first policy box we can select used and type average for the source node and key B for the destination node. For the second policy we can select was attributed to and type key B for the source node and Bob for the destination node. Next, we want to write a policy to ensure that there is some data entity that average salary was derived from. We can construct this policy by first selecting exist. We then enter a variable name, which we choose to be D. We select the appropriate type, which is data entity, and for the policy, we select was derived from. For the source node, we type average salary, and for the destination node, we select D. Next, we want to write a policy to ensure for every data entity, if activity average used the data entity, then the data entity was attributed to either Bob, Alice, or Mallory. To construct this policy, we first select for all, we then enter a variable name D, select the appropriate type, which is data entity, and select the implies policy. Then for the first policy, we select used and type average as the source node and select D as the destination node. For the second policy, we select or, then select was attributed to for the first policy and select D as the source node and type Bob for the destination node. For the second policy, we select or, and for the first policy, we select was attributed to for the first policy and select D for the source node and type Alice for the destination node. And for the second policy, we select was attributed to and select D for the source node and type Mallory for the destination node. If during this study you type an incorrect policy, ProProv will indicate on which graphs your policy did not succeed. You can then click OK, after which you can try again, or click Save and Continue to proceed to the next question. This concludes the ProProv training.